Hello. Okay, today we're going to be looking at atomic properties and the Bohr model of the atom. Okay, so can you turn to page 20 in your booklet? Okay, hopefully you've watched the Brain Pop video, Atom and the atomic model. Okay, so you have a pretty good understanding of what's coming, and we're just going to refine things a little bit here. Okay, so big terms we want to know are the Bohr model, orbit, atomic mass, and atomic number. If you're like Miss Labiuk, I do not have a periodic table yet. Well, don't worry. Okay, turn to the back of your booklet, the last gray sheet, and you're going to notice there is your periodic table. Okay, so you can pull it out if you want to, or you can just leave it in there. I have another one that I'm going to use to reference. Okay. So let's get started here. Okay. The Bohr model of the atom. I'll zoom in here a little bit. Okay. The Bohr model of the atom is a diagram that shows the nucleus of an atom and all the electrons that orbit around it or move around it. Okay. Electrons orbit around the nucleus at set or different distances away from it, and these orbits are numbered starting at the center. So the Bohr model is the model that we study in grade 9 and grade 10 chemistry, and then in grade 11 and grade 12 you build on it and learn some more complexities about it. Okay, so like we saw, the model of the atom is constantly evolving. Okay, so this is a very simplified version, and it makes it really easy for us to understand how atoms bond and how they're set up. Okay, so the first thing is that this is our nucleus. And if you watch the Brain Pop videos, you would know that our orbits are nowhere near this close to the nucleus. They are really, really far away. Okay, but in order for us to draw it, we don't have enough paper for that. Okay, so our nucleus is close. Then comes our first, second, and then third orbit. Just make sure you don't put any electrons on your nucleus. Okay, so inside the nucleus is where we are going to put our protons and our neutrons. We're going to write down how many protons and neutrons we have. And then we always fill our first orbit up first. Then if we have more electrons, we fill in our second shell. Okay, and if we still have more electrons, we fill in our third shell. Okay, and I'm going to show you exactly where those electrons go and how to know what happens next. Okay, so when drawing Bohr diagrams, start filling the first orbit and then continue to the next. Okay, always, like I just said, completely fill in an orbit before going on to the next orbit, and make sure you write the number of neutrons and protons in the center or the nucleus of the atom. Okay, so how many electrons does each orbit hold? Well, we can kind of get a sense from this example up top here. The first orbit only holds 2. The second orbit only holds 8, and the third orbit also only holds 8. Okay, so I'm going to show you a trick for how to figure that out on the periodic table as well. So if you have your periodic table out here, notice how the first row only has 2 elements in it. Okay, well the first row, the elements in that first row only have 1 shell, and the most electrons they can have are 2. Okay, notice how the second row has 8 elements in it. Well, everything in the second row has 2 shells, and the second shell can only hold 8 electrons, just like there are the number of elements in that row. Same thing for period 3. All the elements in this row have 3 shells. The very last shell, the third shell, can only hold at the most 8 electrons, just like the number of elements that are in that row. Okay, I'll show you lots of cool things like that. It makes reading a periodic table really, really easy. Okay, turn the page. Okay, how many electrons does an atom have? Okay. We can determine the number of electrons and protons are in the atom by looking at the atomic number. This will always be a whole number. Okay, you can't have part of an electron or part of a proton. Every different element, okay, has a different number of electrons and protons that make up one atom of that element. Okay, so how many electrons does an atom have? You look at its atomic number. Whatever the atomic number is, that's how many electrons, that's how many protons it has. If you take out your periodic table, in our key here, it shows the atomic number is in the top left-hand corner, and it tells you here atomic number equals number of protons. It also equals our number of electrons. So in this case, carbon has 6 protons and 6 electrons. Right on. Okay, how many neutrons does an atom have? Okay, neutrons are found in the nucleus of an atom. Okay, the atomic mass tells us how many neutrons and protons are in the nucleus. It is the average mass of an atom of the element. Okay, so to put this kind of in a math equation, the number of neutrons equals the atomic mass minus the atomic number. Okay, so let's go back to our periodic table and take a look. Here is our atomic weight. Sometimes you'll see it said weight or mass, both of them are fine. Okay, so the atomic mass is always the bottom number on the periodic table. Okay, and it tells us here that the atomic mass equals the number of protons and the number of neutrons. So if we rearrange that, and if you want to write this down, you can. Okay, the number of neutrons equals atomic mass minus the atomic number. So in this case, carbon, the atomic mass is 12. We're going to subtract the atomic number. So 12 minus 6 is 6. Excellent. Okay. There we go. See, showing you all the little tricks and tips on how to read the periodic table. Okay, now it's time to draw some Bohr diagrams ourselves. Okay, so here I have kind of very lightly sketched in empty Bohr diagrams to make it easier for you to draw them in, because it can get kind of hard. And when we draw them in, okay, so here is our nucleus, and we want to put how many neutrons and how many protons are in the middle. Okay, and then we're going to have the first shell, and when we go to put our elements in for the first shell, we put our first electron here, and then we put our second electron here. So the first one goes at 12 o'clock and the second one at 6 o'clock. Okay, if we have a second shell, okay, our third electron goes at 12 o'clock, then our fourth at 3 o'clock, then our fifth at 6 o'clock, then our sixth at 9 o'clock, and then we come back up again. 7th, 8th, 9th, 10th. Okay, so we always go 12, 3, 6, 9, 12, 3, 6, 9, kind of like a clock. Okay, and we've decided to set up our electrons like this on purpose so that it helps us when we do bonding later on. Okay, so let's take a look at boron. Okay, can you find boron on your periodic table? Okay, so we're looking for the atomic symbol B. Ah, there it is. Okay, so it's our fifth element. Okay, so we know that the atomic number is 5. Okay, so here in my nucleus, I'm going to write P equals 5, and then N equals, and we'll figure out what the neutrons are too. Okay, so I've done my protons. Now I'm going to add my electrons. Okay, so that means if I have 5 protons, I also have 5 electrons. So first one up here, second one down there. Okay, so that now I filled my first shell. Now I can go to my second shell. So that's my third, my fourth, and my fifth. Okay, so now I have done my Bohr diagram for boron. Literally, that's it. Let's take a look at silicon. Okay, right here. If you're like, Miss Labiuk, oh, sorry, I forgot our neutrons. Okay, so what's the atomic mass for boron? Our atomic mass for boron is 11. So 11 minus 5 is 6. Should I add that? There we go. Okay, so if you're like, Miss Labiuk, I cannot write that small inside the box. No problem. Draw yourself a little arrow that points to inside the nucleus, and then you can go like this instead. P equals N equals. Okay? Just make sure you have an arrow that shows where it's going, and an arrow has a little point on the side, so you're showing it goes in the middle. Okay, so find the atomic number for silicone. What's the atomic number for silicone? 14, right on. So we're going to have 14 protons, and then we're also going to have 14 electrons. Okay, so that means I'm going to start up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I have a third row. 11, 12, 13, 14. And we stop. Okay? So if you see that your element is going to have 3 shells, then you know that everything on the inside of it, all the inner shells are going to be full. Okay, that's just a quick tip. Okay, let's try one more. Okay, let's try calcium down here. Okay, so calcium, I'll do the little arrow thing. Okay, and I'll go P equals N equals, oh look at that, I forgot the neutrons again here. Okay, silicone, how many neutrons? The mass for silicone is 28, and the atomic number is 14, so we would have 14 neutrons. Okay, so now let's look at calcium. Okay, calcium, oh, I can put it side by side like this. I'll make it easy to see. Okay, how many protons does calcium have? Good on. Calcium is going to have 20 protons, which means it also has 20 electrons. Okay, so let's fill them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. So I'm going to have 2 more, okay? But because I knew that I have 3 inner shells, I just filled them in, okay? So I have 18, I'm going to go 19, and then 20. There we go, okay? So I have 20 electrons and 20 protons. And how many neutrons do I have? Okay, that's right. I also have 20 neutrons. 40 minus 20 is 20. Okay, and now you've done 3 Bohr diagrams for the periodic table. Right on. Your job is now to finish the rest of these, and then you can check them against mine to make sure you have them down pat. Excellent. Off you go.